Okay, so Unit 6 is all about projectiles. Projectiles is basically throwing things, and we did a little bit of throwing things in the Year 12 mechanics section. We threw things vertically upwards and then they fell back down. This time though, we're going to actually throw things properly. We're going to throw things in a two-dimensional world. So if we think about what example 7 is telling us, it's telling us a particle projected horizontally from a point 78.4 meters above a horizontal surface. So essentially you could think of this as like throwing something into the sea from a cliff face. So if we're 78.4 meters up here, 78.4, and what's happened is that somebody has thrown an object off the edge of the cliff. It'll come down like this and it will land in the sea. Right, so for this one, it says that when we first throw it, it's thrown it horizontally with 25 meters per second. Okay, so it's gone straight across, it's not gone up at all, it's just gone straight across from there and it's come down. Now, before we get started, I want to talk about some base assumptions that we're going to use in these sorts of questions. So the first one is all of the SUVAT formula that we've done before. These are in the formula book, but just to remind you, they're V equals U plus AT, S equals UT plus half AT squared, V squared equals U squared plus 2AS, S equals U plus V over 2, lots of T, and finally S equals VT minus 1 half AT squared. So the 5 formulas that we're going to be using. There's also a couple of base assumptions. So the first one is for vertical motion, because that's what we're going to do with this. We're going to split it into vertical and horizontal motion and think of them as separate elements to the movement. But when we're talking about moving vertically, we have that acceleration will always be minus 9.8. Right, we did this in Year 12. It's because gravity causes every object to accelerate downwards at a speed of 9.8 meters per second squared. We also have that the maximum height is when V is equal to 0, right? That comes from the fact that when we throw an object up into the air, when it turns to come back down, we would say that it has a positive velocity while it's going up and then a negative velocity when it's coming down. So if we want to find the maximum height, we need to substitute V equals 0, because that will be the turning point for the motion. When we're going horizontally, we actually have that A is always equal to 0, right? Because the gravity will not affect the horizontal motion. So if an object was thrown off something and it didn't actually hit the floor, then what would happen is that it would just keep going with the same velocity for the entire time. So we're always going to be able to use A equals 0. Let's have a look at the actual question, what it's asking us. It's asking us for the time taken by the particle to reach the surface. So we have to decide whether this is going to be a upwards that we're going to resolve or across. So for it to reach the surface, what we need is it to be 78.4 meters below the starting point. So 78.4 is in the upwards direction. We need S to be equal to minus 78.4. Right, because that's when it's travelled minus 78.4 down. When it's travelled minus 78.4 down, then it will have reached the surface. So again, like I just said, the acceleration will be equal to minus 9.8, always in the vertical direction. The initial velocity, because this one's been thrown with just horizontal velocity, it's actually got no vertical component in the start. So U is going to be 0 there. It's only got a horizontal component, so think about in the vertical direction, there's actually no speed at all to begin with, no velocity. And then that's enough. We've got 3. I want to find time, so I select my formula to do that. It's S equals UT plus a half AT squared, and this is minus 78.4 equals 0 times T plus 1 half times minus 9.8 T squared. Right, rearrange that, it's minus 78.4, we've got 0 there, 0T, and we divide this by minus 4.9, and that is equal to T squared. Minuses are going to cancel, square root that answer, obviously it's time, so we're only going to take the positive square root, and actually we end up with T equals 2 seconds. Right, so that's the time taken for it to hit the ground. We've resolved in the vertical direction because that was all we knew. we were 78.4 vertically above where the ground needed to be. Then asks us for the horizontal distance travelled in that direction. So if it's asking us for horizontal distance, we better resolve horizontally. So if we take the arrows across, we've got that u this time is a horizontal speed, horizontal velocity, so we can have that u is 25. Again, a is 0, because horizontally it will always be 0 in these projectiles questions. We have that t is 2, and we need to find the distance that is covered in the horizontal direction. Right, so the horizontal distance is given by s, the displacement, and we can pop this into the formula s equals ut plus a half at squared. But what's going to happen? Well, a is 0, so this whole term will cancel, won't it? Right, if a is 0, so s equals 25 times 2, so s is 50 metres. So it's covered 50 metres horizontally in that time.